rotation and then a translation or something like that. So let's give that a try. We'll do a little segment here, and we'll graph this one too. Yep. So we're going to rotate. We'll do the segment CE, 100 degrees clockwise. And then reflect it over the y-axis. Okay, and here are your coordinates. So C is going to be the point 2,5, and E is going to be the point, let's go 5,8. You might not have to. We will, just so people can see it, but I'll explain how you can do it without graphing it as we go, too. All right, so down here, we've got a little bit of room. I think we use every box equal to 2 for this one, just so we can see it better. Otherwise, it's going to kind of go off the page. Okay, so this little segment is at 2, 5. There's C. And then E is at 5, 8. So there it is. There's the segment. We're going to rotate and then reflect. All right, so I want to go 180 degrees and then reflect it. So let's just do it one thing at a time. Don't worry about the reflection. Just do the rotation first. Follow the rule, okay? 180 degrees clockwise. We've got that over here. X, negative y. Okay. So after the rotation, now we have C prime is at -2, -5, and E prime is at -5, -8. Rule, right? Okay, just make everything negative. Okay, well, let's plot that out then real quick, okay? Let's see what this thing looks like after we do that 180-degree turn. So -2, -5 is right here. There's your C prime. And then E is -5, -8. So right here. Okay, so that's been rotated 180 degrees. And now, I want to take that and reflect it over the y-axis. Well, seeing that now, the reflection's easy. Just like we did yesterday, you just count over to the y-axis, count to the other side of it, and there you go. Okay, so this is 1 unit to the y-axis, or 2 units rather to the y-axis, so 2 units on the other side of it. There's your C double prime, I guess now, technically, right? Then we've got 5 over from E, so 1, 2, 3, 4, 5 for E double prime. There it is. Okay, and then it's just a matter of recording down what are the coordinates of those new points we just got after we did that reflection. Okay, so what are the coordinates of C double prime? Where's it at? Yeah. 2, -5, right? And what are the coordinates, somebody else, of E double prime? Yeah, Savannah. -8, yep. So this would be your final answer after that reflection. Those are the coordinates that we had. Now, I don't know if anybody noticed this. Yes? Nope, it's not that. Yeah, this one's just reflected over the x-axis. Now, that doesn't mean every composition is going to do that. This one just happened to work out that way. But usually, a composition you can describe in just one movement. So you can take this rotation and reflection and say, oh, that's really just one reflection. If you want to get from here to here, what really happened? Just one thing reflected over the x-axis. Okay? You're not always going to be able to see that, so it's easier just to do it and then figure out where you're at. Yeah?
I don't know if it says graph that, and we just can do it just like that, using not using the graph. Do you have to graph that?
If it says graph it, you still have to graph it. Yeah, there's still some value in doing that, even if you can do it in your head at this point. Okay, so are we okay with the compositions? I only did one example, but it's really just do the one thing first and then do the other thing second. And if you draw it, it makes it easier. Okay? So I'm not going to do a ton of those. I just wanted to do the one example to show you how that works. But I think you guys, if you can do rotations, if you can do... Guys, quiet please. If you can do a rotation, if you can do a reflection, if you can do a translation, which I think all of us can at this point, then it's just a matter of following the things in order that you're supposed to do. And then a composition is no more difficult than anything else you've done. Question, Zach?
On our homework, are we going to teach our
Protractor? No. Because now that you know these rules, those are the only kind of rotations I'm going to have you doing. So the protractors, well, it was just to kind of figure out what's going on, and from here on out, just follow the rules and you're fine. One is rotational symmetry. We talked about lines of symmetry yesterday. There is a thing called rotation symmetry as well. Not exactly. Sorry. We're going to go back to our square here. Thank you. So if I rotate this square to look for rotation symmetry, what I really want to do is I want to pick somewhere in the picture where I can put that point of rotation so that if I rotate the square, it rotates right onto itself. So where would be a good place to put that point of rotation? Yes, sir. Right smack dab in the middle. So that's the thing that you guys need to figure out when you're looking for rotation symmetry is, can I put a point of rotation somewhere that will let me rotate this thing and have it rotate onto itself? And usually it's going to be right in the middle of whatever you're looking at. Okay? So then the question becomes, okay, yes, so the square does have rotation symmetry, but how many times can I rotate it and have it click right back into shape? Yeah, 4. Okay, now if you have a hard time doing that, I'm going to draw this square 3 more times, rotated. And maybe you have this, and if you do, that's fine, because not all of us can see rotations in our head easily. I know when I was a student, I struggled with this at first. Okay, so let's just assume we're going clockwise rotations again. So if I rotate it just kind of click, this B is going to travel down to where C is. C is going to go over to where D is. D is going to come up to where A was, and the A is going to be over where the B was, like that. Okay, so that would be what this is our point of rotation. Okay, do you guys all see that? I just did one click, it gets me to there. If I rotate it again, I'm going to have A, B, C, D. And if I rotate it one more time, it's going to be B, C, D, A. And then one more click and it's right back to where it started. Okay? So there are, with that point of rotation in the middle, there are 4 different orientations this thing could have. Okay? So yes, it has rotation symmetry, and there are 4 different ways we can do that. Okay? So 4 rotations gets the job done for this one. Okay, so let's take a look at a few other figures here. What am I up to? E, F, and G. So does the triangle EFG have rotation symmetry? And if so, how many ways can I rotate it and have it click right back to where it is? Yeah. There's none. That's right. Or I guess you could say 360, right? If you rotate it 360, if you put that rotation somewhere in the middle there and flipped it all the way around, sure. But any object can do that, right? Any object you can rotate 360 and put it right back where it started. So this one, technically, you would say has no rotation symmetry then. We can't rotate it and put it right back where it started. Okay, how about... Now this one, you have to assume that this is a regular polygon. So I'm not entirely certain that this is, but... Okay, so like it's like a stop sign or whatever. So does this one appear as though it has rotation symmetry in it? Okay. And we'll put some letters on here. H, I, J, K, L.
Wait, is that the way you do it? I thought you could like... Alright, never mind.
And for this one, would be again smack dab in the middle there. So, without actually redrawing the thing like we did the square, how many different rotations do you think I could get on this one? Assuming it's a regular polygon. Every edge is exactly the same length. All the angles are exactly the same. How many clicks do we get? Yeah, there's 8. Yeah. Now take a look. The square had 4. The octagon had 8.
No way.
Notice a little pattern there? If it's a regular polygon like that, and that's only for regular polygons, but if it's a regular polygon, it is the number of sides is how many times you can turn it. So this one, yes, it has it, but it has 8 rotations you can do. Yes?
So is it pretty much if all sides are the same length, then it has rotation?
If it looks like a polygon like that, then yeah. There's some in your homework that are going to be a little bit different. It just kind of depends, but I think based on kind of here, I think you guys can kind of riddle your way through it a little bit. Question, stretching. What? That's a good question. No. Yeah, so the rectangle is only going to have 2. You can do it 180 degrees and then right back to where it started. Yeah. Okay, I'm going to stop there and let you guys start on your homework. You got about 15 minutes.